So example number 2 is our first subtraction problem because there's a subtract sign in the middle instead of a plus sign. So this is going to change things a little bit. My strategy is to get rid of this plus sign and make it addition because we make less mistakes. So what we're going to do is we're going to take that negative, and that negative is subtracting everything behind it. So what we're going to do is we're going to go ahead and distribute that negative to those numbers, because we know subtracting a negative is the same thing as adding. So we're just going to go ahead and make that add. Again, subtracting a negative is going to make that adding. Subtracting a positive is subtraction. And then again, subtracting a negative turns that into a positive. So what I just did is I took care of a lot of double negatives. And we know in math, double negatives are where we make our mistakes. Now notice I only did that to the terms that came after the minus sign. Everything in this parenthesis before the minus sign stays exactly like it is. Now, you could put the parentheses back around your polynomials, but it is not necessary whatsoever. I'm just going to start doing my stacking method. So I'm going to look for my highest exponent, and it looks like 4 is my highest exponent among them. So 3x to the 4th, mark it out. And then I have now this positive 7x to the 4th, since I already took care of the double negative. Then my next highest exponent would be 3, and I do have those. So negative 6x to the 3rd, and then another negative 6x to the 3rd. We'll take care of those here in just a second. I only have this one squared term, so I'm not going to have anything stacked below it because I don't have another x term or x squared term. That's perfectly okay. Then I'm going to have this plus 3 with this other plus 3. So taking care of those double negatives is very, very important, because it looks like if I ignored that minus sign, it looks like these 3's are going to cancel. But once I distribute that double negative, they don't cancel. They actually turn into a 6. I just wanted to point that out, because if you don't distribute that negative and you just try to deal with it, that's the most common mistake, is completely ignoring that this is not really a negative 3. It's subtracting a negative 3. So just trust me, distribute that negative. It's going to take care of so many mistakes. So up here, 3 plus 7 is 10. So now I have 10 sets of x to the 4th. Negative 6 minus 6, again, doesn't cancel like it looks like it might at the start. It becomes negative 12x to the 3rd. That 6x squared that didn't have anything to combine with it is just going to stay. And I have my answer written in standard form.